Hi everyone, in this video, we are going to talk about programming language. Before directly jumping into programming language, it is imperative to have common understanding on what a computer is. There are many definitions of computer floating on the internet, like an electronic device, a smart device, an intelligent machine, etc. In our context, I wish to define a computer using a simple formula. Hardware plus software, combined together forms a live computer. What is a hardware? Hardware is something which is tangible. For example, if you look at a desktop, we have various components like CPU, monitor, keyboard, etc. which you can touch and feel. Those are called hardware. What is a software? We all know the computer does a lot of wonderful stuff for us. It's the hardware which does all those wonders, but it cannot do them all on its own. We, the programmers, have to instruct the hardware to do it. Those set of instructions given to the hardware to do a job is called software. New concepts could be easily understood when related to familiar stuff. I am not sure how many of us are religious, but we all should be familiar with the concept of body, plus soul, and his knowledge makes it a living man. Now let's relate this formula to the one we used to define computer. Body, which you can touch and feel, can be mapped to hardware. Soul and knowledge, which you cannot see, can be mapped to software, and the human to the live computer. I believe now you know what computer is, what is hardware and software, and their relationship. Hardware is the worker who actually does the job for us. Software is the set of instructions given by us to the hardware to do a job. Make a note, when I say the hardware doing jobs, it is the microprocessor residing inside the CPU who does it all. Let's go and see what is programming and what a programming language is. The process of preparing sets of instructions to make the computer to do a task is called programming. Language used to convey our instructions to the computer is called programming language. We just saw, it's the microprocessor who we need to talk to. Let's see what his language is. Yes, it's zeros and ones. Microprocessor only understands binaries. This type of language is called machine language. But it is extremely difficult for humans to deal with machine language directly. It is highly error-prone. Engineers came up with a solution to this problem by introducing human-friendly programming languages called high-level programming language. Here is a sample program written in Java, a high-level programming language. If you are not already familiar with Java, don't be worried what this program does. But we all agree that it is relatively better and easier to read compared to the machine language of zeros and ones. Between high-level and machine language, there resides another level of language called low-level language. For time being, don't be much worried about it, but it is worth knowing that there exists another level of language. We learned that there are different levels of programming languages available, and some are machine-friendly and others more human-friendly. But how the processor can understand instructions from programmers when they talk in high-level programming language. It can understand only machine language. To solve this problem came the compilers and interpreters. When engineers introduced high-level language, they also developed compilers and interpreters to translate the instruction sets in high-level language to machine language. Developer writes instruction in high-level language. Compiler takes these instruction set as input and translates that to machine language. we discussed in brief about hardware, software, programming language, etc. There is one more final entity we all should learn about before kickstarting our programming journey. It is operating system. Even if you don't know what an operating system is, you might have already heard about different operating systems like Microsoft Windows, Linux, Mac, etc. So what is an operating system? It is also a piece of software which takes care of generic, common functionalities required for all applications. Let's think of an application software, say Notepad. Its main functionality is to provide support to create and edit simple text files and store it. To do that, we should be able to feed input using the keyboard, and the response should be displayed in a console, say a monitor. To accomplish the core functionality of create, edit, delete and store, we need support for common basic tasks of collecting input from input devices, displaying the output to output devices, storing information to storage devices, etc. These common tasks are not only required for Notepad but also for every application software. Apart from these, all the modern computers are capable of running multiple applications concurrently. For instance, we can listen to music in Windows Media Player while typing some document in Notepad and copying some file in the background, all at the same time without clashing with each other. So somebody should take care of isolating these processes by providing independent workspace and scheduling CPU cycles, etc. All these generic functionalities are supported by operating system. Without an OS, every application software should take care of implementing these supporting features, which is redundant. It is the OS which acts as a liaison between all the application software and hardware and other peripherals. With that, we have reached the end of this session. I hope we have gained at least the minimum required knowledge to start our programming journey. Let me know your thoughts about this video in the comment section below. Give it a like if you really enjoyed it and hit the subscribe button if you haven't done that already. We'll see you soon in my next video on Introduction to Java. Till that time, bye bye from Eva.